Hello, I'm Quincy Puppetjohn here at a construction site on Washington and LaSalle in Chicago with my friend Amanda, who's an engineer. Amanda, why don't you introduce yourself?
Hi, my name is Amanda Buckley, PE, Senior Engineer and Project Manager. PE stands for Professional Engineer and is the most basic licensing requirement for most engineers and is issued by each state.
Oh, that's very interesting. Could you tell us a little bit about your workload as an engineer?
Sure, workload differs really all the time, especially when I'm focusing on one project for a week. And sometimes it's 4 different things that need to happen in one day. In a day, today for example, I can be sending emails, working on a drawing for a concrete repair in AutoCAD, getting on a call with another HBK team, that's my firm, about a proposal for an upcoming work, and then transition to a calculation package for a suspended transformer in a warehouse in Texas. So, a lot of variation.
That sounds really interesting. I wonder if you could tell us how you became an engineer.
Well, I was interested in math and physics in school, so everyone said I should study engineering. I went to Northwestern, starting in industrial engineering, and quickly switched over to civil and environmental engineering, with a focus on structures after studying trusses in an Intro to Engineering course. With an engineering degree, it's a very straightforward path to becoming an engineer. There are internships and entry-level jobs to break in. To become a licensed engineer, you need to take an 8-hour test and have 4 years of post-grad experience. That's when you can actually sign documents and seal plans.
Wow, that's very cool. I wonder if you could talk about how you use the engineering design process in a project.
Well, so for instance, this week we're wrapping up a structural calculation package for a metal and concrete panel that is subject to truck loading. This is several different pieces of metal welded together with grading in sidewalk level and concrete slabs under the street. One of the HSS sections we were checking was failing, so we thought through our options. 1, we could use a thicker, bigger piece of steel, or sharpen our pencils and do the calc. That's a fancy way of asking ourselves, were we being too conservative with our measures? We looked at how this piece fit into the design and realized a different member would be cumbersome and take an assembly significantly heavier. So we looked at our calculations, which was applying the whole tire load to this one piece, and we realized it was ultra conservative because we were never going to see a full load due to the size and configuration. So applying a fraction of the tire load would be sufficient and more realistic. So we updated our models and reran the calcs and found the solution.
That's such a great example of real-world problem solving. I really liked how you went back and re-examined a problem and looked at potential solutions. Well, we're almost out of time, but I wanted to ask one last question. I wondered, as a female engineer, have you ever felt that engineering is a so-called boys' club?
Well, occasionally yes, especially with the older set of colleagues and contractors, boomers. They are primarily male and can be condescending or dismissive if you aren't prepared or if you don't have their answers right away. But I think that is probably true in most fields with being prepared. In my first job, my group was actually about 25% female, which was actually pretty good for the company. In my current job, my group is 50% female and all the senior engineers are girls. So I feel that we have a really good ratio, but that's definitely not the norm in the field.
Amanda, your job sounds very interesting, and it sounds like it's a lot of hard and very fun work. Thank you so much for taking time to talk to us today.
Oh, you're so welcome. Thanks for coming to the job site.
It was a blast.